Hello students, my name is Dr. Gajendra Purohit and you are watching our YouTube channel where I upload videos for engineering mathematics B.Sc. There is a very important test in infinite series, that is Cauchy's Root Test, which is one of the most asked question in the exams, a question which is based on it, generally asks whether a series is convergent or not. Questions are also formed if convergence comes in terms of x, then for what value of x is it convergent? This concept is related to radius of convergence. When we will study power series, it will be useful. So let's understand this. So students, here if we have any infinite series of positive term and if we find the value of limit n tends to infinity, un power 1 by n, and if it is less than 1. So this series that we have is convergent, okay? If it is greater than 1, then this will be divergent, and if it is equal to 1, then what will happen? The test will fail. Is it clear? Before I talk about this, I taught D'Alembert ratio test, right? And there is relation between D'Alembert ratio test and Cauchy root test. We will see question based on these because both of them have same concept. I will upload a combined video later which will include relationship between these two, and we will discuss question based on that which are formed in exams. See this question, what's happening here? Pay attention. Test for the convergence of the series whose nth term is this. See, it's given here. Here this series has been given as n is equal to 1 to infinity and we have its nth term. We need to find whether this series is convergent. Now a question arises in your mind that it's not clear when this test can be applied. Therefore, whenever we have power n or if we have power n square for any nth term of n infinite series, then in that case we will apply this test here, right? Then if we see its nth term, then what will we get as its nth term? We will get un is equal to n to the power n square upon 1 plus n to the power n square. So this is our nth term, right? So Cauchy root test that we have here, what will it be? Limit n tends to infinity un power 1 by n, and we will find the value of this. Limit n tends to infinity. So like this, n to the power n square upon 1 plus n to the power n square to the power 1 by n. So limit n tends to infinity, we will take the power of this. So here it's n, and if this is n square, then n will remain here. By 1 plus 1 to the power of n will be there. In this n to the power n, you can take n common, I mean from the denominator. When we take n as common, then we will get n to the power n, 1 plus 1 by n whole to the power n. It will be cancelled. N tends to infinity, the value of this will become e. That is 1 by e, so here its value is less than 1. If it's less than 1, it means that the series is convergent. So this series that we have here will be convergent, right? We have to pay attention now. Look at this question. Here the nth term that we are getting, what is it? It's n plus 1 upon n. Power n square by 3n, right? This is its nth term. Now we need to figure out if this series is convergent or not. So we will take limit n tends to infinity, un power 1 by n. Here we will get limit n tends to infinity, n plus 1 upon n whole to the power n square upon 3 to the power n and whole to the power 1 by n. If we take this, then we will get limit n tends to infinity. We will get this when we will take power. This will be n plus 1 to the power n, and when this is n square, this will be n upon 3. If we simplify this, as we have seen that limit n tends to infinity, then we will get 1 plus 1 by n to the power n upon 3. We know that its value will be e, that is e by 3, and this is less than 1. That means this series which we have, it will be convergent, right? You need to understand this properly, students. Let's look at the next question. It has been given like this, and nth term is this. It is asking whether this series is convergent or not. Here we have n plus 1 upon n whole to the power n plus 1 minus n plus 1 upon n whole to the power of minus n. This is the value that we got, right? What are we going to do now? In this we will apply the Cauchy root test. So limit n tends to infinity, un power 1 by n, then it will be limit n tends to infinity. So students, when we will divide this power n, then we will get 1 plus 1 by n to the power n plus 1 minus, and here we will get 1 plus 1 by n. And here we have minus n, this whole thing has power 1 by n. So this n and this n will get cancelled, and here we will get the power as minus 1. And we will get minus 1 power. We will get this as limit n tends to infinity, 1 upon, because power is in minus, so I am writing it in denominator, 1 plus 1 by n. It is power n plus 1. So I will write 1 plus 1 by n and minus 1 plus 1 by n separately here. Clear, students? n and n will be cancelled. Here's minus 1 as power, meaning we will write by doing 1 upon n power is n plus 1. So it will be 1 plus 1 by n power n and 1 plus 1 by n. Let's look at n tends to infinity. So at n tends to infinity, this will be 0 and this will be 0, right? This value that we have, how much is it? It is e at limit n tends to infinity. So 1 by e, and this itself is minus 1. We will get this value, and we know that this is less than 1, which means that this series which we have here is convergent. This way we can easily prove it. So look here for next question. It's given that n cube upon 3 to the power n is nth term of any infinite series. The infinite series given here is n is equals to 1 to infinity. N cube by 3 to the power n is given, and you need to find that if this series is convergent or not. So the nth term that we have, it is given as n cube upon 3 to the power n. It is n tends to infinity. Here I am saying that you can apply the Cauchy root test, or you can also apply the D'Alembert ratio test. Okay. Now you will say, sir, as there is power, so can we apply the D'Alembert ratio? Yes, we can absolutely apply it. In a single question, you can apply 2 to 3 tests. And what you can do here, use which one is easier, use which has less calculation. So this will be power 1 by n, and we will get limit. N tends to infinity. We will get n cube by 3 to the power n whole power 1 by n. Now we will calculate its value. So it will be limit. N tends to infinity, n power 3 by n upon 3. We will get this, and if I write it this way, then this will be limit n tends to infinity. N power 1 by n whole cube upon 3, we will get this. Now we know that n power n at limit n tends to infinity will become 1. So this will be 1 cube upon 3, that means 1 cube upon 3, that is 1 by 3. And we know this is smaller than 1, it means that this series will be convergent. So in this way, we can prove it easily, right? Now, the next question is asking us to test the convergence of this. So what is the nth term given here, students? We have the nth term given here as n plus 1 upon n to the power minus n square, and what we will get here? We will get limit n tends to infinity, right? We will take you n power 1 by n, then we will get limit n tends to infinity. And if I take this here, let's divide it by n. We will get 1 upon 1 by n, and we will get power minus n square power 1 by n. N and n will be cancelled. Limit n tends to infinity, and n over n will be cancelled. Minus n power will remain. Then 1 upon, this is 1 plus 1 upon n power n, and we know that 1 by e is smaller than 1. Hence, this series is convergent. See the next question, test the convergence of this series, and here we have the nth term given. Now students, the nth term we get here will be 5n plus 1 by 4n plus 1 to the power n, and here we will use the same Cauchy's root test. I hope this is clear. We will get limit n tends to infinity power 1 by n, and here we will write limit n tends to infinity. Then we will get this as 5n plus 1 upon 4n plus 1 to the power n whole to the power of 1 by n. We will get n tends to infinity, then 5n plus 1 upon 4n plus 1. Now we will take n as common from here, then the limit n tends to infinity, take n as common here, so 5 plus 1 by n, and we will take n as common again, then 4 plus 1 by n. N by n will be cancelled. When limit n tends to infinity, this and this will be 0. Therefore, we will get the value as 5 by 4, which is greater than 1, and if it's greater than 1, this series here is divergent. After we put limit and apply Cauchy sequence test, if the value we get is greater than 1, then the series is divergent, and if it is less than 1, then the series is convergent. Clear, students? On the other hand, if the value comes as equal to 1, then we can't say anything about it. Then we will apply another test for it. Understand this. Students, this question is for the comment box. Tell me how much milliseconds did you take to solve this. Like, share, subscribe the channel. On infinite series, you can find more videos here. If you are preparing for CSIR, NET, GATE, IIT-JAM and want to improve your short tricks, you can find the entire playlist and watch other videos here, and please subscribe to the channel. Thank you very much to all of you.